MODERNAGE MCQs Physics First Year Unit number 8 Waves Part 1. A piece of cork is placed at the surface of still water in a ripple tank. When a vibrator generates ripples in water, the piece of cork, option A, moves along ripples, option B, moves vertically up, option C, moves vertically down, option D, vibrates up and down. The key is vibrates up and down. Therefore, the correct option is D. Reason: the waves do not shift matter from one place to another along their direction. The water waves are transverse waves. Therefore, the particles or molecules of the water of the medium vibrate perpendicular to the direction of motion of waves. Hence, the piece of cork vibrates up and down. The maximum vertical displacement of molecules of water due to a moving pulse in a river tank is option A, equal to amplitude of pulse, option B, less than amplitude of pulse, option C, greater than amplitude of pulse, option D, displacement of pulse. The key is equal to amplitude of pulse. Therefore, the correct option is A. Reason: the waves do not transfer matter in the direction of propagation. The water pulse raises the molecules of water to the top of crust, which is the amplitude of wave. Therefore, the maximum vertical displacement of molecules of water due to pulse is equal to the amplitude of water pulse. Hence, the maximum vertical displacement of molecules is amplitude. A mechanical wave cannot travel through option A, air, option B, vacuum, option C, water, option D, mercury. The key is vacuum. Therefore, the correct option is B. Reason: a mechanical wave can be generated in material medium only. The vibration of particles of the medium propagates wave from one to another place. Hence, the mechanical waves cannot travel through the vacuum. The sound of fusion explosions in sun can be heard on earth in option A 12.3 minutes, option B 10.4 minutes, option C 8.5 minutes, option D none. The key is none. Therefore, the correct option is D. Reason: the sound waves are mechanical waves. They can travel through the matter and not through the vacuum. Therefore, they cannot reach the earth because there is vacuum between sun and earth. Hence, the sound of fusion explosions in sun cannot be heard on earth. The portion of a transverse wave above the mean level is known as option A, amplitude, option B, displacement, option C, crust, option D, trough. The key is crust. Therefore, the correct option is C. Reason: the statement of question is the definition of crust, that is, the portion of a transverse wave above the mean level is known as crust. Hence, the portion of the wave above the mean level is known as crust. The portion of a transverse wave below the mean level is known as option A, amplitude, option B, displacement, option C, crust, option D, trough. The key is trough. Therefore, the correct option is B. Reason. The statement of question is the definition of trough, that is, the portion of a transverse wave below the mean level is known as trough. Hence, the portion of the wave below the mean level is known as trough. In the propagation of transverse waves, the particles of the medium vibrate with respect to the direction of propagation of wave at option A 30 degree, option B 60 degree, option C 90 degree, option D 120 degree. The key is 90 degree. Therefore, the correct option is C. Reason. The transverse waves are those waves in which the particles of the medium vibrate along a line perpendicular to the direction of propagation of waves. Hence, the particles of medium vibrate at 90 degree to the direction of propagation. In the propagation of longitudinal waves, the particles of medium vibrate with respect to the direction of propagation of wave at option A 0 degree, option B 30 degree, option C 60 degree, option D 90 degree. The key is 0 degree. Therefore, the correct option is A. Reason. The longitudinal waves are those waves in which the particles of the medium vibrate along a line parallel to the direction of propagation of waves. Hence, the particles of medium vibrate at 0 degree to the direction of propagation. The speed of a wave pulse in a string is directly proportional to option A m, option B square root m, option C t, option D square root t. The key is square root t. Therefore, the correct option is D. Reason. The formula for the speed of a wave pulse in a string is V is equal to square root T into L divided by M square root, where T is the tension in the string, L is the length of the string, M is the mass of the string, or V is proportional to square root T. Hence, the speed of a pulse is directly proportional to square root T. The speed of a pulse in a string is inversely proportional to option A m, option B square root m, option C t, option D square root t. The key is square root m. Therefore, the correct option is B. Reason. The formula for the speed of a wave pulse in a string is V is equal to square root T into L divided by M. In this case, T is the tension in the string, L is the length of the string, M is the mass of the string. Therefore, the speed of pulse is inversely proportional to square root of the mass, which is m. Hence, the speed of a wave pulse is inversely proportional to square root m.